On y va. Bonjour, Devoxx France. Pour les personnes qui ne me connaissent pas, je m'appelle Stephan Janssen. Je suis le créateur de Devoxx, Devoxx Belgique. Et je suis pour moi, c'est plus facile de parler en anglais. Comme ça, je switch en anglais pour the rest of the talk, if you don't mind. You're welcome. I was hoping, actually, last year I did a talk here, and I had also subtitles, but I was using translation, using ChatGPT, so it was translating what I was saying into French. So next year we need to have that as well, right? So it shouldn't show English sentences, but it should just translate it automatically, right? So anyway, who's already doing RAG? Not that many people. Who's already playing with large language models? Okay. How many people are using a Copilot-ish type of plugin on their daily jobs? I would say 40%, something like that. Okay, thank you for that. So I actually started playing as well with, of course, large language models, etc. And for me, I mean, I've developed the CFP together with lots of other enthusiasts like Arnaud, who's now helping me for Devoxx France, Louis, who actually did the Angular migration to Java 17. He's going to talk about that tomorrow. But it's a playing ground. So for me, it's like, oh, okay, I want to do something with RAG. So I developed this chatbot using LangChain4j. Who knows about LangChain4j? Not that many people. You'll definitely going to give you some pointers. And so I was asking a question. So basically what I was doing is that I was indexing the whole database using the REST interface. And then I was asking a question, how many talks did Brian Getz give at Devoxx Belgium? And funny enough, the answer was 2, which was wrong. He gave 4 talks. So I was going like, bloody hell. This is like the chatbot where Air Canada, they actually released the chatbot as well, and they removed it from the website because it was constantly hallucinating. Right? And so hallucination is really, really an issue. Even with a stupid example like I did with how many speakers or how many talks a speaker gives. And so I wanted to get this response. 4 talks by Brian Getz at Devoxx Belgium. Why didn't it give me the right answer? No, not co-speakers. So I went like, why? So I went like, okay, I need to understand what's going on. And as a developer, you like to open the toys and see what's inside, etc. And that's basically what happened with me. I started a journey where I wanted to start debugging this RAG type of environment. And this is what the talk's about. And this reminds me a bit about a quote from Richard Feynman. I would rather have questions that can't be answered than answers that can't be questioned. And I would actually want to change that to the next quote. Because hallucination is a big issue. And this is also one of the reasons why I didn't release the chatbot publicly. It was only a beta internally within the different CFP instances, because it was definitely not ready for production. Not at all. Right? So what I want to do is actually give you the journey of the RAG eval prototype. I call it a prototype because I almost didn't develop any unit tests. Right? If it's prototype, you can just it's just playing with code and see what happens, and I don't need to have 100% coverage of JUnit. I did write some unit tests nevertheless, but anyway, what I did, I chose Angular, because I already had developed that for the CFP. Spring Boot, of course, at the back end, of course in Java, preferably Java 21, not 22, and I'll talk about that later on why. But most importantly, I've also chosen to use LangChain4j. And LangChain4j actually basically got announced at Devoxx Belgium last year when Liz Raas talked about that. And I actually was working together with the founder to do some semantic search in the CFP. And since, October last year, they've really, really boosted in the Java ecosystem. And there's actually 3 very important talks tomorrow which go in much greater detail than I will do, because I will not go and show you how to develop it in Java. You can go to those talks. I will talk about what are the problems, what are the things you need to think about, and not so much the code. But tomorrow at 10:30, I think there's multiple people from Microsoft talking about that. They're really, really involved in helping this project, this open source project forward. Liz Raz is actually coming and she speaks fluently in French. She's basically like the DevRel of an open source project, which is LangChain4j. And then you can even meet some developers. Even Antonio is now being involved and actually does some pull request and source code committing. So definitely look at that. So I want to have a 10,000 feet view first. Because if you would ask anybody here in the room what's RAG, you will all have a different answer. Some will do some simple RAG, which I call naive. It's a naive RAG approach, which actually that's what I did with my first chatbot. But there's some really, it's becoming a science. And I want to actually go through the flow and show you a bit what the options are, what steps and decisions you can make using the following chart. The first thing you need to do is you need to ingest, you need to load data into your store. This can be anything. I mean, this can be a file, this can be even a GitHub project, which I've done. So you can take a full GitHub project and basically ingest it and then start vectorizing all the content of what the data represents in that GitHub project. What you normally do is that you use text splitters, and that's where already the problem is, text splitting. How do you do that? I'll go into more detail in that. But basically, you're converting your documents, could be anything, could even be images. It could even be audio, right? So it could be very broad. You split it in chunks, and then you store it. You basically embed it, and you store it into a vector database. Then the user asks a query, a question. How many talks did Brian Getz give? That question is embedded again, so you convert it into a vector. I'll talk about that later on. And then you do a similarity search in your vector database. Now, it becomes much more difficult because I actually noticed when I said, how many talks did Brian Getz give? Or how many presentations did Brian Getz give? I will get a different answer. Because presentations and talk might have a different similarity. So you go like, I don't control the user. He or she might say talks or presentation. How the hell can I anticipate that? Well, there's things which are called query transformers, which is on the left here. A query transformer will actually generate subqueries. It will create variants of the different questions, and you have one question, but it will turn into 5 different similar questions, and then those 5 questions, or 3, whatever you choose, will actually be used to find similarity documents. So that's already, you know, a danger, because it could go in all different directions, right? LangChain actually supports this. So if I say LangChain, I mean LangChain4j. There's also a Python version, but I'm focusing on the Java version. LangChain already supports subqueries as well. So you can even say, give me 3 questions based on that question, but that call results in a large language model trigger. So it slows down the processing of getting an answer. Then the other thing is that it could be that your answer is not in your vector store. You need to maybe do a search. So you might want to use SERP API, which does a Google search, right? And then based on the Google search, you can actually get the web pages and use that as a context to answer a question. Yeah? If I would have said, how many talks did Brian Getz give at Devoxx 2022, it will not have the data source, so it could go actually to the internet, right? Or it could even use a tool, which is this one, agents, or tools as they call it as well, which is basically calling a method function. So it could be like a REST API, where it says like, I have a REST API called talks@devoxx_Belgium/2023, and it knows about the parameters, a bit like Swagger, and it would actually trigger that function call to get the answers back. So that's already less than the ordinary simple RAG thing. You could already have your own data source, you could have tools, and you can go into the internet. Okay? Then the other thing that once you have the similarity, you will actually give these documents that it found similar to your question, you will take that and put it as a context in the prompt. But there's something there between which is called the re-ranker. What is a re-ranker? A re-ranker is based on the algorithm BM25, best match 25, and it will actually do some non-large language model optimization of the result set, and it will actually find the different chunks where it says Brian gets, and it will only include those where it said Brian gets, and exclude the other ones. The problem with this is that, well, actually, LangChain supports it, because Cohere is an LLM provider. They have this service, which you have to pay for, which does re-ranking of your result set. And once you have to pay for something, I don't like that, especially if you're an open source developer. So I said like, oh well, we have lots of rainy weekends in Belgium, probably in France as well. So during a rainy weekend, I developed my own BM25 algorithm. By the way, I'm not smart, I'm an average developer, but I'm becoming an expert because I use ChatGPT, I use Claude to assist me, and as a result, I'm becoming a productive expert developer, just thanks to these extra systems that I can use. And so in one weekend, I developed my own BM25, which I'm now using, and most likely LangChain will actually adopt this and use it as the free version instead of the paying version. The link is, well, you can see the QR code. So we are re-ranking the result sets, we pump it into a prompt, then we go to the large language model, say, okay, give me an answer to this question with this context, and then we have an output. And you would say, oh, that's it, it's finished. No, it's not finished. Because what you want to do is that you want to also have a memory. You want to know, hey, what was my previous question? If you don't have memory, it doesn't know that. It only has like a request response. So you want to include some chat memory, and the best way to do that, to also condense the context window, is to summarize every question and answer. So you use less tokens to actually add to the prompt context while you're chatting away. Right? And so this is the chat memory, which also LangChain supports. That's it, right? It's already an interesting architecture. It's not finished yet. What you would then also do, you know, sometimes you have the thumbs up, thumbs down. Well, the thumbs up, thumbs down actually gives a confirmation that the answer was correct or not correct. If it is correct, you can actually feed it as the good Q&A or the good questions type of thing, and include it as a data source for future similar questions. And so you're basically having a loopback of what is answers, what answers are good or ones which are false. And so that's basically what you can more or less already do with LangChain. So if you go to the LangChain website, they have like the naive implementation, which is basically the simple flow, and you have the really advanced implementation, which is that. And you can do this all yourself as well, step by step. Cool. So that was my plan. I wanted to develop something like that. So I went like, I'm a person, like I go full Monty. So I'll do all the LLM providers. So what I did is that, okay, the prototype, remember the prototype I developed? And by the way, I'm open sourcing the prototype today for you so you can play with it. But what it does, I wanted to have Ollama, LM Studio, and GPT4All, which are LLM providers locally running on your Mac. No internet needed. Right? And Ollama supports, it's actually what's it called, Llama CPP behind it, which allows you to download multiple models, like 10, 20, 30 different open source models, and have it run on your Mac or Windows via the Ollama API. I did not have time to do the Apple MLX. The Apple MLX is a native Apple implementation for large language models. And then on the commercial side, the cloud LLMs, I supported all of these in the prototype. There is a small gotcha with Gemini. I was unable to get that working. Why? Because of the European Union. They don't really allow you to have an API key yet because of regulations, but I've been told by Google that eventually, in a couple of months, we'll be able to use Gemini as well. And so now that I have all my providers, by the way, they're all supported by LangChain, I could actually have a question and just see at all the different LLMs how they respond, which is great. So the first thing I need to do is the importing of data, as you remember from the chart. Very easy. If you want to import text, HTML, PDF, Office documents, there's solutions out there. If you want to do JSON imports, REST, or like GitHub, you have to custom build your own data loaders. I've actually built custom in the prototype that you will be able to download for both JSON and REST. I'll show you that later on. Cool, so we got importing of data. By the way, the document loader for HTML pages uses JSoup. You probably know this. But it would be better to actually also have a Selenium WebDriver, which, if it's a highly JavaScript-enabled website, the JSoup will just say there's JavaScript only there. It doesn't show any content. If you use the WebDriver, it will actually give you the content of a JavaScript-driven website. So, but that's something you need to build on a rainy weekend. So splitting. So how does it work? There is to split or not to split. That is the question. Yeah? Because 1 year ago, the maximum context size was 4K tokens. Yeah, it's like 12,000 words. That was it. These days, we're talking about millions of tokens. So like Gemini has a window context of 1 million tokens. 1 million tokens can have like any project that you have here could be put into the Windows context, and it will find an answer in that big chunk of text. It's scary. That's scary. But it's going to cost you, right? It could be $120 for one question if you have a 1 million context window. $120. And then, oh, you put an open chatbot online, and then people start asking, you're like, stop, because you're going to pay for it, right? But it could be like, well, maybe 200K is enough. Like Claude from Anthropic does a 200K Windows context. It's going to cost you like $2, something like that. If it's for sophisticated, like if it's for refactoring my code base, $2 is cheap, right? Especially if you have to pay a senior developer to do it otherwise. So there's some trade-offs there. But also the response time, yeah? If it's a small context window, it might be in milliseconds. If it's a 1 million context window size, it might be 10 minutes. So you need to already evaluate, the size, etc., and the cost and the response time. But what is very important, I think it's always a combination of both of them. You will not say, I don't do chunking. Why? Because with chunks and giving it a good context, focused, laser-focused, you can avoid, or not avoid, you can reduce hallucinations. And that's really important if you want to have a commercial product giving you right answers. So the splitting strategies, if people begin with drag, the simplified ones are these here, which are supported by LangChain. Very, very simple. It's one-liners, as you can see on the right. So you can do per word, per sentence, per line, per paragraph, or you can do a recursive one, which does all of the above recursively. But if you want to do some really advanced dragging, then this is a talk you should watch on YouTube. It's by Greg Kamrat. He spoke at Devoxx Belgium last year. I invited him to talk about LangChain, but the Python version. And he's talking about the semantic meaning of sentences and chunking not by a word or by a sentence, but by the semantic meaning chunking. So we might group all the talks from Brian into a Brian Gets corpus, for example. And so there's some very interesting first implementation. One is from Llama Index, which is the semantic splitter node parser. And then the other one is the agentic chunking, where it will actually more or less do summarization of your chunks. So you will have your chunks of text, but then we will summarize the chunks so it's smaller, and then group these and actually have like a linked list of summarizations so we can have actually smarter responses. There's all sorts of very exciting and I would say more or less R&D type styles of implementations, but this YouTube talk from Greg is a really good start. Raptor is another one. There's many one. The one I implemented is the chain of density, sorry. The chain of density is in the prototype, so you can play with that, but it's basically linked summaries. Cool, so enough talk. Let's do a demo of the prototype so you can see what I've been working on for the last 2 months, basically. Okay, see if it's still running. Yep. So it looks very similar to the CFP. And basically what you can do on the left, I have all the language models. So here you can actually see all the different language models, their context size, the cost, etc. And I did not add Gemini yet because I don't have an API key. But you can see that Claude from Anthropic actually has a context size of 200,000 tokens. One token is about, like, it depends on the embedding, but it could be 3 words or a few characters. You multiply it by 2 or 3, more or less. And then the beauty is, I'm running this locally, so I have Ollama running locally on my machine, so I can actually access all these large language models when I'm on the train or when I'm in the car where my wife is driving and I'm hacking. I can just continue and have I would say, an assistant helping me with the code and improve it, etc. Right? So that's the overview, basically the options I have to do my evaluations. Then I have the embedding models. I haven't spoken about this yet, but I've added multiple embedding models. So this is where words are converted to vectors, floats, ideally, and it gives meaning to the numbers. Right? So I can actually mix and match, and embeddings have certain dimensions. So I started with 384 dimensions, but you have embeddings which have 3,800 dimensions. The more dimensions, the more meaning you have for a word, but the more cost of storing that information. And so here in my import data, I can import data from text, from a web page. I can even do an import from a web search, from files, OpenAPI, and GitHub. Then I can do the splitting. So I've already imported 3 pages. And the splitting, for example, here on the FAQ, I can select the splitting I want to use. So for example, recursive, a chunk of 550, and an overlap of 25 characters. And then I can say split, and I can visually see where it is splitting, which is really important, because if it splits right into the middle because your window was too small, you will lose semantic meaning. Right? So you have to really, and this visualization really helped me a lot to find bugs actually, where it was just splitting in the middle of a sentence because my chunk size wasn't big enough. And then I can say store in a database, vector database, but I can select which embedding I'm using. Now this is crucial. The embedding you choose will have an impact on the results of your queries. So you have to really play with different embeddings. Right? You will see different answers or questions that will not be answers because you chose an embedding which was too low, for example. And then once I say, okay, store in the DB, I can go into the DB, which is here, but now, this is beauty. Normally, you would just have a vector DB and you have nothing, you don't know what's happening in there. There's just arrays of floats. I've actually listed all the chunks, so I can see where the answers are coming from. And there was another rainy weekend in Belgium where I wanted to visualize also the embedding. So this is like, you can see the vector points. What I wasn't able to do, the project is open source, so you can help me, but I would want to like go over a point and then know what it is. So you could see how far it is from another point, because similarity is basically done on different algorithms. One is the cosinus similarity, where it will actually calculate the distance where the node is from each other, and based on the distance, further or closer, they will be closer or further from the semantic meaning, right? So that's the vector database. I'll come back to that one later on when I do a bit more about vector store. So for the vector store, you have these floats, an array of floats. You need to store them somewhere in the database. You have a lot of options. There's a really, the last year or so, there's been a rush of new vector databases. There's a really cool talk by Alexander. He's from the Netherlands. It's on the Devoxx YouTube channel, where he compares all the different vector databases. Have a look at that. It's beautiful, visualized, unbelievable. He's like a game developer. Wow, I get goosebumps here, seriously. It's such a good talk, you should watch it. I decided to go for PG Vector because I was already using Postgres DB. Now, the problem with Postgres, there's a few issues. One, you need to have PG Vector extension installed. And the CFP is running on Clever Cloud, a French beautiful company doing hosting of the CFP instances, but they didn't support the extension until 2 months ago. I really pushed Quinten, say, oh, Quinten, I need PG Vector, because I wanted to store the vectors of the embeddings. It works. I've got it running in the cloud. It runs. But what you need to know from PG Vector is that the index that it uses to do the similarity fast enough only goes to 2,000 dimensions. Now, 2,000 is enough for certain embeddings, but if you're doing the OpenAI embeddings, they go to 3,400 dimensions. So you can't use PG Vector for OpenAI embeddings. So you already need to like mix and match a bit what embeddings you want to use. You can do embeddings reduction, which is what I'm doing with the graph. What it basically does is that it takes like a 3,000 vector and it reduces it, to, for example, to 200 vectors by doing some smart mathematical calculations. But then you lose some meaning, of course, so you have to watch out for that. So embedding is really, really important. It's basically a numerical representation of a piece of information, capturing the semantic meaning of what's being embedded. So if I have how many talks did Brian Getz give, depending on which embedding I've chosen, I might get 384 floats in an array like that. And then if you want to embed, it's very simple. LangChain has a default embedding in memory, which is the all-mini LM L642 V2 embedded model. You give it some text, and it gives you an array back of floats. So very, very simple to do, very fast, but it's not the best one to choose. So it's good for some prototyping, but production, don't use that one. I've got some really bad results on that one. And so LangChain actually supports multiple ones you can have locally, or you can actually have it as a service. So like OpenAI, Nomic, Hugging Face, etc., they support different embeddings. And so I remember, I think it was Emmanuel Bernard who was doing a search on the CFP where I was already doing semantic results on the queries. And I said, I didn't get any response. But it was the first time we were using the CFP for a French content-based talks. And so what happened is that these embeddings are actually language-specific. If you want to have French meaning, you need to have a French embedding model. Bloody hell, I didn't know that, right? So Cohere has actually, version 3 of Cohere has a multi-language embedding. The problem is LangChain doesn't support it. So what do you do if it's a rainy weekend? You just develop it yourself. So I developed the Cohere version, the full Cohere version implementation, not only the embeddings, but also the generation, the auto-completion. It's on that website. And I've been told they will include it also in the LangChain for J project. So we will have full Cohere support with multi-language. So I can go to Emmanuel Bernard and next year say, do a search in French. It works? It's going to work. Cool. So embeddings, dimensions, it actually has limitations. I didn't know that either. So why didn't my first chat didn't work, the chatbot? I was actually giving chunks, big chunks of JSON, and say, here, a big chunk of JSON embedded. But what I didn't know is that it has actually a maximum input. Certain embeddings will only go to like 300 tokens, and everything behind it, it will drop it. So even if you're splitting at 500, but your embedding only allows 300, you're losing 200 tokens or characters in the process. It's like, bloody hell, you have to really think about this. It's not just, oh, hello world, like, I think there's a talk, 30 minutes rack, yeah, sure, right? For a hello world demo, but not for production. So you need to think about this. It's even crazier. Like even OpenAI says, well, we have 3072 dimensions, but we actually allow you to chop it at 2000, and the 1000 tokens that we're missing, just gone, doesn't matter, we have enough information. Yeah. But it might hallucinate. So you have to really think about this. Is it the dimensions, which embeddings you're using, etc. And then it's storage. So you have these embeddings. If I have an embedding of some text, the text might be like 100 characters. The embedding might actually be 2 megabytes because I'm using a 3000 dimension vector embedding. So the storage is really, really important. If you go for the embedding version 3 of Cohere, you might actually have for the Wikipedia embeddings of 250 million pages, I believe. It will take about almost 1 terabyte, and it would cost you $43,000 to host that content. That's a lot of money. You have to host it somewhere, right? But what is happening now is that Cohere and others are starting to do quantization of embeddings. So instead of using a float 16, they will say, no, we'll do quantization and do embeddings in an integer. The other extreme is that, no, we'll do it in bits, 0 or 1, bitnets. What? How is that possible? How can you have meaning in a 0 and a 1 for certain text you want to embed? It's happening. It's called binary embedding. The difference is that instead of 1 terabyte, I only need 30 gigabytes, and it's only cost me $1,300 a year to store it because the size is much smaller. So that's interesting. So I said, well, I'll develop that one. So I added it to Cohere. So I added a binary and a U-binary. Well, I used ChatGPT and I used Claude to help me assist. But basically, I have now, in the project I open sourced, you can actually do binary embedding of your contents. And the beauty is, the loss of meaning reduces depending on the model size. So if you have a model of like 100 billion parameters, the difference is only 0.09 between one where you have like a floating point of 16. So it actually gets better, the bitnet one becomes better if you have a bigger model. So there's some really, and this is research just published last week. It's very interesting, very exciting. But if you're working on the latest and greatest, sometimes not everybody yet supports it, of course. Take a picture of this one because this shows you the memory needed for binary vectors versus float vectors, the accuracy, and also the latency, the response time. And so you're losing a bit of meaning if you go to binary, but there's a big upside where the hosting cost is less. So what you could do is you could have different versions of responses because you have more data that you can store now because it's a smaller footprint. So you need to really think about these things. And this is definitely a trend happening, is that a float, a 16-bit float, is often overkill. And you can actually do it with an integer. So that's what I did. I did it with an integer, and then all of a sudden, bang, LangChain doesn't support it. Because LangChain, the core embedding class of LangChain, is float-based. So I'm losing my flexibility. This is here an example where I'm using the integer embedding. So you can see there the JSON array, it just has integers instead of floats. But if I want to store it in LangChain, it just needs to be boxed out to a float. So I will need to talk to Liz and Dimitri about this because that's going to be an issue, right? Moving forward. Antonio, you heard that? Cool. So I continued with my ranking. So I developed then a similarity search. I then did a Q&A, and then I wanted to evaluate all the different responses. So what I did is that I had like these default questions, like how many talks did Brian Getz give? And then I executed that on all the LLMs, on all the different embeddings, and then compared it in my prototype, what actually gave the best results. And it didn't come as a surprise. Well, there was 2 surprises. One surprise was that the small embedding was better than the default embedding from LangChain, which is on the next slide here. So don't use the all mini LM L6 one. Use the small one, which has better performance and better accuracy. But it doesn't come as a surprise that Claude and ChatGPT 4 do give the best results. They're the more commercial ones. Claude Opus is better than GPT-4. However, last week, OpenAI released an update of GPT-4. Some people call it GPT 4.5, and they're jumping just above each other constantly. So and there's some new players being added to the mix. It's very, very interesting to see how that goes. But this really gave me a mean to actually measure what the best results I'm getting from these experiments. So let me I think I didn't do the demo, but basically here I can do a similarity search, just selecting a question and an embedding model. I've only done 2 embeddings, that's why it's only giving me 2 options. And then I can even play with the re-ranking. So I can say like, how many talks did Brian give? And then I can select like this. It doesn't matter, it should know, there it is. So it gives me these 5 answers. It gives me the similarity. Now the similarity, I said everything above 60%, but you see like small gives me up to 88. If I would change it to the other one, the similarity is actually much lower. There you go, 60 and 60. So even there, with this parameter, like the minimum score, could have an impact on what you get back. So you need to measure that, you need to know this, otherwise you will just not get any results. And then I can even enable my re-ranking, and if I do the re-ranking, poof, it only returns me the 2 ones from Brian. If I go back and choose the other one, which is a better one, that's my answer. So I've got the 4, that's what I inject in my prompt, I will get the 4 answers. However, depending on which depending on which large language model you will choose, you might get different answers. So let me see here. Let me get the bad ones. So here, I'm expecting this answer, and with Gemma, Brian Guts gave total of 3 talks. So it's already wrong, right? So you can actually play and see how it actually behaves depending on the combinations, not only of the embedding, the models, the chunk size, the splitting strategy, etc. There's a lot that can go wrong to get hallucinated answers, unfortunately. Okay. Still got 12 minutes. So what are the lessons learned? Well, embedding models have an input limit, so don't give a chunk which is bigger than the input limit. Who knew about this? Nobody. So 1 person, sorry. So you learned something already. No, but seriously, that's a really important one. If you give it too much data and it cuts it off, you will lose meaning. The bigger the embedding dimension, the higher the hosting costs. Think about that. It's not that you go, oh, let's go to OpenAI and so on. You will have terabytes of data, right? And I mean, you need to be able to pay for that. Multi-language embeddings is a thing. So remember, if you have French text, you have to choose the right embedding model that supports multilingual, or support your language. The quality of your embedding influences the quality of your results. Really important. If you go for something cheap, you will, what is it? Garbage in, garbage out. It's basically that, right? Leverage and test the power of the different LLMs. So I'll show you the link to the project. Use it, abuse it, change it, commercialize it, I don't care. But you can use it for your own project and actually evaluate it, right? So that's really important. So log and debug your context. See what's being added to your prompts, what's missing and why. Double check the vector database support dimensions. If you go with PG vector, you're limited to 2000 dimensions. If you want to have the 3000s from OpenAI, you might want to go with VV8, which is another very good open source vector database. And use a framework. I would say LangChain4j. If you're doing Java, do LangChain4j. If you're doing Python, just use LangChain or Llama Index. They're great frameworks. And you can learn a lot even as a developer if you don't use Python, how they do this. So, one more rainy weekend in Belgium. We've been having lots of rain, right? And so yeah, you just sit at home, it's raining, you can't walk with the dog, there's no basketball game in the evening, so you might as well hack. So what I did is that I said, wow, I've got all these large language models. I've got Ollama running locally. When I'm driving to a basketball game, sitting next to my wife, I want to have this assistant. Wouldn't it be nice if I could have like Ollama and an agent who's using IntelliJ? Okay, 80% of the room. So what I did over last weekend is that I actually built a plugin. There he is, the Devoxx Genie in IntelliJ. And the Devoxx Genie, what it does, it allows you to select code, like here, and I've added all the large language models from my prototype. So all the cloud ones, but also all the local ones. So I can, if I'm on the plane, traveling to wherever, I can go to Ollama, select whatever model I downloaded, so like Mistral, and then say, explain, for example, which is a predefined command. And now it's going to talk to my local instance of Ollama, so I don't need any internet. It will look at the code which I selected, and it will actually analyze and come with some stupid suggestions because the model isn't powerful enough to do sophisticated code, but it will try to do something. So almost 6-7 seconds, comes with a response, and I can do whatever I want. The beauty is I just added also cloud-based, so the expert in the room is Anthropic, this one, and then Opus. You only have access to Opus via the developer API. So I've added it to the plugin. I can ask the most expert person here in the room, Opus is smarter than you. Seriously. So I can select some code, and it will come up with refactorings, which I went like, bloody hell. I posted it on my Twitter yesterday. It was already a very sophisticated code which OpenAI ChatGPT made for me, and Opus was still able to make it even better. And the unit test was still working. Look, I get goosebumps again. I was like, how's that possible? So, and then you put this project in open source, and people go, wow, Stephan, he writes really clean code. No, every single line went through Opus, right? So it cost me a bit of money, but I get the best quality code out of it. So that's something, I would say it's my new pet project. It's called Devoxx Genie. It's on the marketplace as of yesterday on the IntelliJ marketplace. So if you go to your IDE, go to plugins, marketplace, Devoxx Genie, you will have that version downloaded. It's free, it's open source. I'm looking for contributors if you want to help and implement the tap autocomplete thing. Let me know. It's full Java, so it's 100% written in Java and 100% open source. And it's only going to get better. Man, I have some crazy ideas. I still have like 5 months for Devoxx Belgium, so I have like another 2 months of quality time that I can work on this project. I mean, I'm already supporting local models, so Ollama, LM Studio, and GPT4All. On the train from Bruges to Paris, I added all the cloud providers, so they're all there, but that's in version 0.6, so you have to install that one manually because I haven't published it yet on the marketplace. You can customize the commands, so you can go into the settings and say, /test, it now says, write me a unit test. But you can say, no, write me a JUnit test version 4 for whatever is selected. So you can customize that to your own needs. But what I want to do is that I want to be able, which I already have in the prototype, I want to be able to have your full project and use that as a context to answer your questions into the plugin, which I have already started in the prototype. So what I want to do is support, well, first of all, I want to vectorize your complete project because the plugin is already in your project. So it should be able to just vectorize your complete project, and you choose which vector database you have, so it should be pluggable. So if you have a V8 instance on Docker running on your Mac, it could just talk to that one and populate your whole project into the V8 instance. If you don't have it and you have it in the cloud, you could just give it a URL and it goes to the cloud. So now we have the context. Once it's everything is vectorized, maybe with binaries, so it doesn't take too much space, so why not? Then you can do RAG based on the question you asked, not only on the selected code, but also on all the similarity requests it found of your project. So if you're using a DTO or a record somewhere else, and it knows about this, it might say, hey, you should use this one, etc. So it's much smarter in answering. Wouldn't that be cool? I mean, why not? And then what you could do, think about this, you could orchestrate large language models. So Claude has 3 different versions. It has Sonnet, which is very cheap. It has Haiku and Opus. So Opus is the smart one. I think Haiku is the cheap one. So you can use Haiku for simple things, and more like for refactoring more smart engineering things, you can use the more expensive one. So you can do orchestration of different models based on what they're good at, and actually come up with a good answer based on what you're looking for. So we've just scratched the surface. This is just a fun time to be a developer, seriously. I mean, I've been in this industry for a long time, but I still have so much energy and so much enthusiasm because this was not possible 1 year ago. So what's going to be, in the next month? It's a week-by-week thing because there's so many things going on. So the other thing you could do, let's say you have a corporate license to Gemini. It has a 1 million context window. You can put your whole project in the prompt, your whole source code in the prompt, ask a question, migrate it from Hibernate X to Hibernate Y, and it will just do it for you. So it will not replace our job, don't worry about it, we're smart enough, but we will be more productive. You can bill 1 week of consultancy and do it in 1 hour. Why not? It's definitely the sky is the limit. And so these are, if you only have one picture, this is the picture where we have the prototype. So it's on GitHub, I released it last night. And the Genie plugin, if you want to look at the code, or join and contribute, just look at the different URLs. And I still have 3 minutes left of my extra 5 minutes, so thank you, Arnaud, for that. Thank you for your attention. I hope you learned something. I'll be here all week, so don't hesitate to come to me with questions. But I still have 2 minutes and 40 seconds for any questions, so thank you for your attention. Any questions? If not, it's a 30-minute break, so just come over here and we can talk about it. Have a great Devoxx France.